Good morning. Let us now continue with maxima and minima. In the previous video, we had taken the basic concept of maxima minima and the first derivative test. Today we are going to take up the second derivative test for maxima and minima. And this is the one which is used more often, and it is a very simple test to apply. Only in case we find this at some stage, if suppose we find using second derivative test difficult, only then we go for first derivative test. Okay, so let's see. So all the questions which we had already discussed under first derivative test and by the basic can also be done using the second derivative test. Now in this case, consider a function f(x) which is continuous and differentiable in some interval. Okay, so now the steps involved in the second derivative test are: first point is that we find all critical points. So what is the meaning of critical points, which is also called as turning points of the function? Okay, so that is, we put f dash x equal to 0 and we find the value of x corresponding to f dash x equal to 0. Okay, then we divide it. Now second is, at each of the critical points which is obtained by putting f dash x equal to 0, f critical points, okay, we find f double dash x, and then we do the analysis as under. First part is that f double dash x, if it is less than 0 at a critical point, say x equal to c, then it implies that x equal to c is a point of local maxima. Now this is slightly typical that you have to, the common norm is that greater sign goes with maxima, but as far as the second derivative is concerned, if f double dash x is less than 0, it corresponds with maxima, and in case f double dash x is greater than 0 at a critical point, say x equal to c, then it implies that x equal to c is a point of local minima. However, if f double dash x is equal to 0, okay, at a point, then that point is neither a maxima nor a minima, and we call it point of inflection. Okay, now the point of inflection is found out, like for example, let's take up this, if f(x) equal to x cube, okay, you find the first derivative, you get 3x square, equate it to 0, you get x equal to 0. Now you find the second derivative, you get 6x. At x equal to 0, second derivative is equal to 0, and it implies that x equal to 0 is a point of inflection. Okay, neither a maxima or a minima. And when you draw the graph of this function, the graph of this function is something like this. So if you just see, this is x axis, this is y axis, this is the point x equal to 0. And if you just see at this point x equal to 0, the function on the left also it is increasing, and on the right also it is increasing. So it's neither increasing nor decreasing, and so there is no change in direction as you move from left to right along the x axis. there is no change in direction of the function, and so x equal to 0 is called as a point of inflection. Okay, so with this you can do all the questions which we had done earlier also, and of course the other type of questions also. Like for example, we had taken up a question which we did by the first derivative test, which was fx equal to, we had taken this as fx equal to x cube minus 3x plus 3, which we had done by first derivative test. Okay, the first two steps remain the same, that is we first find the first, this was example number 29 which we had taken earlier also. So what we do is first we find, now to find critical points, we find the derivative. Okay, so we differentiate the given function fx with respect to x. So what do we get? F dash x is equal to 3x square minus 3, we equate it to 0. Okay, so this gives us 3 times x square minus 1 equal to 0, which gives us 3 times x minus 1, x plus 1 equal to 0, which gives us x equal to 1 and minus 1 as two critical points. Till here we the procedure is the same as what we did in the first derivative test. Now for the second derivative test, what we do is now differentiate it again. Differentiate again with respect to x. Now what we get is f double dash x is equal to, now here this one 6x. Okay, so when you find f double dash x is 6x, and now we have to check the nature at the two critical points. At x equal to 1, f double dash x is equal to 6, which is greater than 0. So it implies that x equal to 1 is a point of minima, and this is what we had found out in the previous question also. At x equal to minus 1, f double dash x is minus 6, which is less than 0, which implies that x equal to minus 1 is a point of maxima, and this is what we had found out earlier. So you can clearly see that this method of finding maxima or minima is very simple as compared to using the first derivative test. Now let's take up the question which we had done by the basic concept, which was fx equal to 2x minus 1 whole square plus 3. So let's do this by the first derivative, second derivative test. So first of all we find the derivative, you get 2 times 2x minus 1 into 2, because we apply chain rule. 2 times 2x minus 1 into derivative of 2x minus 1 is 2 plus 0, which is equal to 4 into 2, that is 8x minus 4. Okay, so put f dash x equal to 0, this gives us 8x minus 4 equal to 0, which gives us x equal to half as the critical point. Now you find the second derivative of this, it is 8, which is greater than 0, and so we conclude, see there is only one point which we have found out, and this derivative, second derivative is free from x. So we so whatever nature it is indicating, that nature would be followed at that critical point which we have found out. So f double dash x is 8, which is greater than 0. It implies that x equal to half is a point of minima. Okay, and so the minimum value of the function is at x equal to half and is given by f of half equal to, just substitute over here, 2 into half minus 1 whole square plus 3, which is 0 plus 3, which is 3, and this is what the answer which we had found out. So using this second derivative test, you can try out any and every question which is given to you. So just try out the remaining questions of question exercise 6.5. You can try all questions from 1 to 10, and from 11 onwards we'll take up in the next video. Thank you.